Yeah, good afternoon, folks. We'll just give it a moment or two just for people to join. Okay, I'll just give another minute. People are still filtering in. Uh, Colin, I see you have your hand up. The way this webinar is configured is that we can't actually see you or hear you, but we do have the chat and the Q&A function enabled. So please feel free to use those. Okay, folks, the numbers seem to have settled down. Listen, you're very welcome to today's webinar. It's the title of which is Protecting Workers from Silica Dust, Essential Guidance for the Construction Industry. And this is brought to you by the construction professional Skillnet. There will be an opportunity to pose any questions to the host today. So please use the Q&A function rather than the chat, and we'll endeavour to respond to those queries at the end. On behalf of the Construction Professional Skillnet, we're delighted to be joined by Catherine Healy. Catherine is an occupational hygienist at Shore Control Safety with a PhD in occupational health and hygiene, a BOES diploma in professional competence in occupational hygiene, and over 13 years of practical experience. Catherine brings unparalleled expertise in occupational health. Catherine's PhD research focused specifically on respirable crystalline silica dust amongst stone workers, the findings of which were published in leading occupational hygiene journals. So without further ado, I'll hand you over to Catherine. Thank you.
Thank you very much. Good afternoon, everybody. My name is Catherine. I'm an occupational hygienist with Shore Control Safety. And I'm just delivering this webinar this afternoon, just on respirable crystalline silica exposure, focusing specifically on the construction sector. So respirable crystalline silica in the construction sector, it has been a sort of hot topic at the moment, and it has been in the media a lot during the past few months, basically primarily because of the health and safety and the authority, the HSA and national inspection campaign. So as many of you are probably aware, on June 9th, the HSA did begin, a 2-week national inspection campaign focusing on respirable crystalline silica dust exposure in the construction sector. So this campaign sort of aimed to highlight the serious risks associated with exposure to silica dust. And so the overexposure to respirable crystalline silica is quite commonplace in the construction sector because so many materials that contain varying concentrations of respirable crystalline silica are handled in the construction sector. Okay, so that's why they focused their efforts on the construction sector. So like the primary aims of the campaign, really, they wanted to make employers aware that they should be, number one, identifying the hazards associated with respirable crystalline silica and carrying out task-specific risk assessments. So if you're handling or cutting or grinding or fabricating any sort of material on your site that potentially contained crystalline silica, that you are identifying that hazard. And then for the task that was using that particular material, that you were carrying out a task-specific risk assessment. So that just means looking at the individual exposure scenario and identifying, was there a potential risk of overexposure to respirable crystalline silica? And if there was, were you implementing appropriate control measures to reduce exposure to as low as technically possible? The HSA during this campaign, they also assessed whether appropriate control measures were in place to eliminate exposure where possible and to reduce exposure. So since respirable crystalline silica is categorized as a category 1 carcinogen, you do have a legal obligation under the Carcinogens Directive to reduce exposure to as low as technically possible. And we'll look at a bit later, you should be doing that following the hierarchy of exposure controls. And usually sort of the main route of doing that is implementing engineering control measures. So the HSA, we're looking, were you using appropriate control measures and were they being used correctly? And then finally, they're also looking at proper use of RPE, so RPE, respiratory protective equipment. In a lot of sites, it's still the main line of defense. A lot of people are still solely relying on respiratory protective equipment to reduce exposure to respirable crystalline silica, which is poor practice. And so they were looking at was, RPE, sort of the main line of defense against exposure, and if it was it correctly used, was it fit tested, etc. Okay, so I have not been I'm not sure if they have communicated the results of this campaign yet. I haven't heard any feedback from it, but this is sort of the main reason why, silica dust was present in the media a lot during this summer. So what is crystalline silica? Okay, so crystalline silica is a common mineral found in the Earth's crust. So we have crystalline silica and we also have non-crystalline or amorphous silica. So the non-crystalline silica is much less hazardous, and from an occupational health perspective, there's not a whole lot of serious health effects associated with exposure to non-crystalline silica. It's the crystalline silica which is the most hazardous form of silica. So it's the crystalline silica that has all of the, hazardous health effects associated with it, like silicosis and lung cancer and COPD, for example. And so there's three types of crystalline silica. There's quartz, cristabolite, and trimodite, okay? And the cristabolite, for example, is really only present in occupational environments where heat is applied to the crystalline silica. So foundries, for example. So it'd be unusual to find that form of crystalline silica on construction sites. Quartz is the most common form of crystalline silica. So crystalline silica and quartz are usually used interchangeably because quartz is the most common type of crystalline silica present in most workplaces, especially the construction sector. So crystalline silica is found in a lot of materials that are handled in the construction sector. So it can be handled or it can be present. So crystalline silica may be present up to 70% in concrete, for example, depending on the aggregate used. Sandstone has a very, very high silica content. Quartz obviously is a very high silica content. So quartz is the form of crystalline silica which is of concern from an occupational health point of view. So it's very, very important to be aware of the silica content of the stone or the materials that you are working with. So when you are trying to identify, if there's a potential risk of exposure to respirable crystalline silica in your workplace, and the first part of your risk assessment is obviously to identify the hazards. So to identify the hazards associated with the material that you're working with, you need to know sort of the silica content. So you can see here on this slide, the silica content of materials, it really does vary greatly. So sandstone, for example, is extremely high silica content, 70 to 90% silica content. So if you're working with sandstone, even for a very short duration, you are potentially at risk of overexposure to respirable crystalline silica. Concrete has a huge range of respirable crystalline silica. So you can see there approximately 25 to 70%. So if you are handling concrete, drilling, chiseling, grinding concrete, for example, it could contain up to 70% crystalline silica. And depending on the aggregate used, so all depends on the aggregate that is used in the concrete, that will typically determine, what is the silica content of the concrete. So you could potentially be exposed to very high levels of silica if you're handling concrete. You can see there tile, granite, and slate. They all contain, quite high levels of silica, not as high as sandstone or quartzite, for example, but potentially if you are, handle cutting or grinding them for even, a relatively short period of time, you are at risk of potentially being overexposed to silica. Limestone and marble are really sort of the low silica content materials. So if you're handling limestone on your site, you are at risk of overexposure to limestone dust, which is an ocular irritant, is a respiratory irritant, but it's not as hazardous as respirable crystalline silica. You don't have to worry about respirable crystalline silica, which is much more hazardous than limestone dust. Limestone dust is really just an irritant. So it's very important when you're carrying out a risk assessment to know what material is being handled, because the silica content does vary greatly. So what is respirable crystalline silica? So basically, if you are handling, if you're cutting or grinding or polishing or chiseling, if you're working with a material that contains crystalline silica, when that crystalline silica in the material, when it's fractured or crushed or drilled, for example, that dust that is released up into the air is called respirable crystalline silica. It's extremely fine, okay? And the particles are typically 10 micrometers or smaller in size. And that means that they can penetrate deep into the alveolar region of the lungs, okay? And respirable crystalline silica is chemically inert. So when it does enter your lungs, it just sits there, okay? And it's chemically inert and it causes fibrosis or scarring of the lungs. The lungs basically develop scar tissue around that silica dust in your lungs, and it causes fibrosis of the lungs. So because respirable crystalline silica is so fine, it can often be invisible to the naked eye, which makes it very, very dangerous. So somebody might be under the illusion that they're not, that, a lot of dust isn't being produced, that they're not potentially exposed to crystalline silica during a particular task because they can't see any dust. But if you shine like a Tyndall light, for example, at the dust cloud, you'll see it very clear. So that's another important thing to remember, that respirable crystalline silica is so fine that it may be invisible to the naked eye, okay? And it can also remain suspended in the air for quite a long period of time. So you might be finished a task, but if you enter the area or somebody else enters the area, they may be exposed because it's still suspended in the air because it's so fine. So you can see on the picture there at the bottom of that slide, so like respirable crystalline silica, it's up to 100 times smaller than a grain of sand. So it just emphasizes again how fine this dust is, and it can enter your lungs very easily. So the health effects of overexposure to RCS, so RCS is just short for respirable crystalline silica. And so silicosis is probably the most, I won't say it's the most common health effect. It's often misdiagnosed as COPD, but it's probably the most well-known health effect of overexposure to respirable crystalline silica. So respirable crystalline silica can cause a range of health effects, but it targets the lungs are the primary target organ for respirable crystalline silica. And so silicosis, as I mentioned previously, it's as a result of inhaling respirable crystalline silica, and because it's chemically inert, it just sits in the lung and it causes scarring or fibrosis of the lungs. And that basically reduces the oxygen exchange capability of your lungs, okay? So there's 3 types of silicosis. There's acute, accelerated, and chronic silicosis. So acute and accelerated silicosis would be very rare in the likes of Ireland in the developed world, okay? It would be more common in developing countries where operators are exposed to extremely high concentrations of silica over a very short period of time. Whereas chronic silicosis would be more common in the developed world. And chronic silicosis it develops when you're exposed to very small concentrations of respirable crystalline silica over a long period of time, typically your 40-year working life. And COPD is another common result of overexposure to respirable crystalline silica. And then we have lung cancer as well. So silica is categorized by IARC as a category 1 carcinogen. So it is a category 1 carcinogen, which means you do have legal obligations under the Carcinogens Directive. And exposure to respirable crystalline silica does increase the risk of developing lung cancer. And smoking also greatly increases your chances of developing lung cancer, obviously, but also silicosis. So this is just a good image here, and it just demonstrates the very, very small concentration of respirable crystalline silica that you have to be exposed to in your 8-hour shift before you're at risk of developing, health effects associated with respirable crystalline silica. So the amounts needed to cause, lung cancer, silicosis, COPD, they're very, very small. So the current OELV, that's occupational exposure limit value for respirable crystalline silica here in Ireland, currently it's 0.1 milligrams per cubic meter. And that's an 8-hour time-weighted average. So the 2024 Code of Practice for the Chemical Agents Regulations here in Ireland has an occupational exposure limit value of 0.1 milligram per cubic meter. So what that is that the maximum concentration of respirable crystalline silica you can be exposed to in your 8-hour shift before you're at risk of developing the health effects associated with exposure. So you can see the little small amount of respirable crystalline silica dust next to that English penny. That is the equivalent of 0.1 milligrams per cubic meter. So it takes a very, very small quantity of respirable crystalline silica before you're at risk of developing the health effects associated with overexposure. So respirable crystalline silica in construction. So respirable crystalline silica exposure is an issue in the construction sector just because it is a major constituent of many construction materials, okay? Such as bricks, tiles, concrete, mortar, and even engineered stone. So engineered stone contains quite high concentrations of respirable crystalline silica also. So because it is a major constituent of many construction materials, it's just really, really important that it's on your radar and that you're aware of this hazard and that you make efforts to, implement appropriate control measures. So construction tasks, typically that cut, break, grind, or braid, or, for drilling concrete, mortar, stone, so anything that fractures that crystalline silica. So if you have materials that contain crystalline silica, and if you're fracturing that crystalline silica via cutting, drilling, anything that fractures that crystalline silica, there is a risk of that crystalline silica being released into the air as a very fine dust, respirable crystalline silica. Okay, so respirable crystalline silica is present on most construction sites to a varying degree, depending on the silica content of the material being worked with, and obviously the exposure scenario, which would be, the task that is being carried out, the engineering controls in place, etc. So I just popped in this slide here out of interest. So these are some, occupational exposure values that are present in the construction sector. So I just looked through some peer-reviewed journals, and these were a result of occupational exposure or occupational hygiene monitoring being carried out and during various tasks that typically occur in the construction sector. So demolition, for example, you can see occupational exposure values range from 0.01 to 0.9 milligrams per cubic meter. These are all 8-hour time-weighted average exposure values. So these would be all exposure values for an 8-hour shift. So if the current occupation exposure limit value for Ireland is 0.01 milligram per cubic meter, you can see that then the upper range for demolition, drilling concrete, roofing, tuck pointing, and concrete milling, they all exceeded the occupational exposure limit value significantly. Okay, so these would all be high-risk tasks. So when we are measuring your exposure to respirable crystalline silica in the workplace, and we're comparing it to the occupational exposure limit value, an occupational exposure of 30% or less of the occupational exposure limit value indicates that engineering controls are effective. However, if you're handling a CMR, which would be a carcinogen, a mutagen, or a reproductive toxin, which respirable crystalline silica is, we like to see the exposures no more than 10% of the occupational exposure limit value because they're such hazardous substances. So you can see here that all of these tasks, all of these tasks that are typically carried out in the construction sector, you can see that some of the exposure measurements did exceed the occupational exposure limit value. So those operators are at risk of developing adverse health effects associated with exposure, and you would have, a legal obligation to reduce exposure as low as technically possible, as soon as possible, okay, to reduce exposure to safe levels. So just to mention the current legislative overview in Ireland, okay? So for most chemical agents that are handled in an occupational environment, the occupational exposure limit values will be detailed in the Code of Practice, okay? So there's a 2024 Code of Practice for the Chemical Agents Regulations that's published by the HSA. And the current occupation exposure limit value for respirable crystalline silica here in Ireland is, as I mentioned, 0.1 milligram per cubic meter, 8-hour time-weighted average. So that's the maximum that you can be exposed to in your 8-hour shift before you're at risk of developing adverse health effects. For a lot of chemical agents that would exert acute health effects, there is also a short-term exposure limit value, or a STEL. That's the maximum concentration you can be exposed to in a 15-minute period, up to 4 times a day, but you have to have a 30-minute non-exposure period between those 15-minute intervals. There's no STEL or short-term exposure limit value for respirable crystalline silica because RCS doesn't exert acute health effects, it exerts chronic health effects. Okay, so it's very important to mention in this code of practice that respirable crystalline silica is also listed in Schedule 4, which is the list of carcinogenic substances, mixtures and processes, and they involve work involving exposure to respirable crystalline silica dust generated by work processes. Because respirable crystalline silica is a Category 1 carcinogen, it also falls under the Carcinogens Directive. So the Carcinogens Directive includes, it covers all carcinogens in the workplace. And since last year, it also covers reproductive toxins in the workplace also. So now any CMRs in the workplace are covered under the Carcinogens Directive. So because respirable crystalline silica also falls under the Carcinogens Directive, you have a legal obligation to reduce exposure to as far as is technically possible. Okay, if it's a non-CMR substance, you have a legal obligation to reduce exposure to as low as practically possible. But if it's a carcinogen, you have a legal obligation to reduce your exposure to as low as technically possible, which means you really have to make every effort possible to reduce exposure to safe levels for your employees. Okay, and you do that by using the hierarchy of exposure controls, which is elimination, substitution, use of engineering controls, etc. Okay, so you have to ensure, so if you carry out a chemical risk assessment and your chemical risk assessment indicates that the operators are potentially at risk of overexposure to respirable crystalline silica, you should get an occupational hygiene or an exposure assessment survey carried out for your operators. That will determine whether they are exceeding that occupational exposure limit value of 0.1 milligrams per cubic meter. All right, and if they are exceeding that occupation exposure limit value, then you must put improved control measures in place to reduce their exposure to as low as technically possible. So the health risks associated with exposure to respirable crystalline silica, they're almost entirely preventable when exposure to dust is adequately controlled. Okay, so you can see there an image of a lung, so one healthy lobe and then one lobe that has been damaged by silicosis. So silicosis is an irreversible disease, okay? Once you develop silicosis, there is no treatment for that, it's irreversible. So it's so important that we reduce exposure to respirable crystalline silica to prevent silicosis in the first place, because it is incurable. But it's entirely preventable, almost entirely preventable, when we put the appropriate control measures in place to reduce the operator's exposure. Okay, so the first step to controlling any chemical hazard in the workplace, as you're probably well aware, is to carry out your risk assessment. And then if your risk assessment indicates that there's potentially a risk of overexposure, then you should carry out an exposure assessment. And if the exposure assessment indicates that the operators are definitely overexposed when in comparison to the occupation exposure limit value, you should reduce exposure to as low as technically possible using the hierarchy of exposure controls. So it's just important to mention as well, the current occupation exposure limit value for silica is 0.1 milligrams per cubic meter. This is considered quite a high occupation exposure limit value for silica. In the States, for example, the ACGIH, their TLV is 0.025 milligrams per cubic meter, which is a quarter of our OELV. A lot of countries have an exposure limit value of 0.05 milligrams per cubic meter. So a lot of countries have a much lower legal limit for respirable crystalline silica, but in Ireland it has remained 0.1 milligram per cubic meter. primarily due to the fact that, the HSA and other sort of occupational environments like the construction sector, primarily the quarries, they also realise how difficult it would be to reduce exposures to those levels. There's also where it's also restricted when we're measuring respirable crystalline silica to such low levels when operators are handling low silica content materials. But it's just important to be aware that the occupational exposure limit value for silica, there is a high chance that it will be reduced in the near future. And so when we are reducing exposure to a chemical agent in the workplace, we use the hierarchy of exposure controls, okay? So the first step in the hierarchy of exposure controls, or the most effective way of reducing exposure to any chemical hazard, would be elimination, okay? So if you can eliminate the hazard, that's obviously the best way of reducing exposure. So it's we realize that the elimination of many materials in the construction sites, we can't eliminate concrete. Sometimes if you're carrying out restoration work, you have to use high silica content materials like sandstone. So, it's hard to eliminate sort of high silica content materials in the construction sector. So the next best option would be substitution. So the next best option to reduce exposure would be substitute the material with a less hazardous alternative. Again, we realize that substitution can be quite difficult or impractical also. So realistically, in most workplaces, it is, a combination of engineering controls, administrative controls, and PPE. So it's a combination of those that's used to reduce exposure to respirable crystalline silica in the workplace, especially on the construction sites. So when we are carrying out a risk assessment, so in order to, assess the risk associated with a particular task, we need to first look at the material. So we need to look at the silica content associated with the material. So if the operators are handling, sandstone or quartz, for example, we know straight away that's a high silica content material. If they're handling concrete, we don't know. Sometimes the SDS may indicate to us, the silica content of the material. If we know the aggregate that is contained within the concrete, if it's coming from a sandstone quarry, then we can guess it's probably quite a high silica content concrete. For example, sometimes we can take samples and the lab can analyze the quartz content of the material, and then that we know that way, what is the silica content associated with the material. But if we are handling concrete, it's usually better being safe than sorry, you know what I mean? So it's usually just safer to assume there is respirable or there is crystalline silica present in that concrete. And the next thing we have to look at is the task. Okay, so the task is really important when we are assessing, what is the risk associated with the task. So if you're carrying out a high energy task, for example, with a console, if you're grinding, if you're using a grit blaster, that's a very high energy task, and that's going to produce much more respirable crystalline silica than a low energy task, okay? If you're using a console without an on-tool shroud, for example, that's going to produce much more respirable crystalline silica than if you're using a pneumatic chisel and you're directing the cloud of dust directly into an LEV arm, for example. So you need to look at the task, what's the potential risk of overexposure during that task? And it'll usually be quite obvious just by observing the task. The next thing you have to look at, another important part of the exposure scenario, is the work area. If the operator is, cutting or grinding a material in an enclosed workspace, there's obviously a much higher risk of overexposure than if he is carrying it out in the yard in the fresh air. However, it's really important, I need to point out, if you are working outside, please do not assume that the respirable crystalline silica levels are low. So sometimes if the operator is working outside, dust might be, depending on the actual containment or the contaminant cloud, depending on the tool, the actual exposure or the contaminant cloud might be directed up towards his breathing zone. If it's a still day and not much breeze, the dust can still be going up into his breathing zone. And sometimes the wind might actually push the dust up into his breathing zone more so. So please do not assume if the operator is working outside that he is exposed to low levels of silica. I have measured many, many tasks outdoors, and the levels have been very, very high indeed. And time, obviously, you know, the longer the task takes, the higher the potential risk of overexposure to respirable crystalline silica. But as I mentioned, because the exposure, the safe exposure limit for silica is so low, even if you're carrying out work on a high silica content material like sandstone, even if it is a very short period of time, even 5-10 minutes, that can be enough to push the operator's exposure above the occupational exposure limit value for the day, because the safe limit is so low. And then frequency, of course. I mean, if you have an operator that is cutting for 4 hours or 7 hours in every day, he's obviously more at risk of overexposure than an operator that would be carrying out a bit of repointing work, you know, once a month. So all of these things are very important. It's what we call the exposure scenario. All of these elements are very, very important when you're carrying out your risk assessment to determine, is the operator potentially at risk of overexposure to silica dust? Okay. So when we are talking, especially on construction sites, I mean, construction sites, the operators are highly mobile, so it can be hard to implement engineering controls. And when you are a mobile operator in a construction site, if you are in a fixed location, for example, if you're in a workshop and you're in a fixed location for your entire shift, it's much easier to implement control measures there. You can work in a downflow booth, for example, in a crossflow booth. So it is important to remember that you have to have specific control measures for mobile workers on site, and it can be slightly more challenging. We, you know, realize that. So as we look at the hierarchy of exposure controls, you know, elimination and substitution, they're usually not options when we are reducing exposure in construction sites. So the next best option is the implementation of engineering control measures. Okay. So the best way to contain and remove silica dust is at source. So that would be using your water suppression, on-tool water suppression, for example, or on-tool local exhaust ventilation. So you are suppressing or capturing that dust as it is produced so that the operator isn't exposed. And again, the surrounding operators aren't exposed as well. So the most common preventative measure is to use water suppression, okay? So the HSA like to see water suppression on site. So that's just applying water at source, okay? The source of the dust. So it's applying water to the cutting or drilling points to suppress the dust at source before it becomes suspended. So that prevents the operator from becoming exposed, and it also prevents the dust being, you know, dispersed into the wider environment. Where it's not feasible or sufficient to use water suppression, the next best option is to use local exhaust ventilation. Okay, so that would be your on-tool shrouds, for example, or your on-tool local exhaust ventilation. And then sometimes the best way to do it is just to amend the task. So for example, use a paver or a block splitter, for example, instead of cutting. So if you can eliminate the task that is resulting in exposure altogether, that's even better. So we're just going to mention water suppression. So the HSA, they really do like to see water suppression as sort of the primary way of reducing exposure on construction sites. And then that would be followed by, you know, onto local exhaust ventilation. So water suppression is a really effective way at reducing respirable crystalline silica exposure. All right. So basically the water suppression system, it has several parts. It has a shroud with a spray nozzle, okay, and a water source. So sometimes the water source can be mains water, or sometimes it's a pressurized water bottle. And so just to mention that water suppression, if you pre-wet the material, it's not really an effective way of reducing exposure to respirable crystalline silica. So a lot of operators, they would pre-soak a material, for example, or they would apply water on the material before they work. That has been shown not to be an effective way of reducing respirable crystalline silica exposure. You have to apply the water at source, okay? So when you have the shroud and the spray the mains water or the pressurized water bottle, they just provide a constant stream of water to the blade, for example, and that suppresses the dust at source. So it's very important when you're using water suppression to have an adequate flow rate, for example, so that there is a sufficient amount of water present to, dampen down the dust cloud as it is being produced. Very, very important to mention the sludge, okay? So if you are using water suppression on site, it's very, very important that you have a way of getting rid of the sludge. So when you dampen the dust, the sludge is going to be produced. If the sludge is just left there and it dries, if operators are driving over it in forklifts or if they are walking over it, that dust is going to become resuspended and you're going to be potentially exposed to respirable crystalline silica from that resuspended dust. So it's very important that you have control measures in place to clean up that sludge, okay, and dispose of it safely. So typically for slurry containing respirable crystalline silica, you should be using a wet H-class vacuum. H-class is very important and it has to be fitted with a HEPA filter. So I do see water suppression being used on site a lot, which is great. However, sometimes the sludge or the slurry isn't being cleaned up appropriately. And that is, there is a risk of, that drying out and then it being resuspended and then you're exposed to respirable crystalline silica. So just keep in mind the safe disposal and safe cleaning up of the sludge when you are using water suppression. So the next best option is to use on-tool LEV. So LEV is local exhaust ventilation. Okay, so this is very, very effective as well because it's capturing the dust at source. So when you're cutting, when you're grinding, when you're chiseling or chasing, when the dust is being produced, it's being sucked away at source. So it's just like a vacuum system attached to the tool itself. Okay, and it is very, very effective if used properly at reducing the dust at source. So you're reducing the operator's exposure, you're reducing cleanup, and you're reducing exposure of the operators around the person carrying out the task also. So when you're choosing onto local exhaust ventilation, it can be retrofitted onto your current tool. So there's a lot of LEV systems or on-tool shrouds like dust buddies, for example, that you can purchase and retrofit them onto your existing tool, or you can use a harmonized system. So for example, if you're buying, a Hilti grinder, for example, you can purchase a specific shroud for that tool from Hilti, so it's all compatible. So it's very, very important that the shroud you're using is compatible with the tool. So you can use a retrofitted system or even better, a harmonized system. Very, very important to involve your workers in the selection process. Behavioral intervention is extremely important when you're introducing any engineering controls on site. You have to involve the workers. You have to ensure that it is comfortable as possible for the operators to use, that it's practical for them to use, and that they can still carry out their task and it's not affecting the quality of the task. So that is a very important piece of advice, to involve your workers. And, it's been shown time and time again, if you involve your workers in the selection process, they're much more likely to actually use the tools. Very important to have a H-class vacuum fitted with a HEPA filter attached to your on-tool LEV system. Okay, and again, it's very, very important if you have any LEV system or extraction system on site, your maintenance. Don't forget your maintenance, that it's very important to clean your filters and to change your filter bags at regular intervals to ensure, the ongoing effectiveness of the tool. And don't forget the cleaning of the filters and the changing of any filter bags or filtration systems on site. That's also classed as a high-risk task. Okay, so make sure you have appropriate control measures in place when you're carrying out that task, because there is a risk of exposure to respirable crystalline silica during that task also. Okay, so just some other very important things on the construction sites. You have to clean up any dust. So any tasks that, that have been carried out that produce dust containing respirable crystalline silica, the cleaning up of that dust has to be done in a safe manner, okay? So the dust still contains respirable crystalline silica. So please avoid dry sweeping at all costs, okay? If you are dry sweeping, you're resuspending the dust and you're potentially exposing yourself or the operator to respirable crystalline silica. You're exposing people in the vicinity to respirable crystalline silica also. So please avoid dry sweeping at all costs. It's just going to resuspend that dust. You must use a vacuum cleaner, okay? A class M or H vacuum cleaner, or ideally wet cleaning. If you can, apply water suppression to the dust and then clean it up, that's even better again. But please avoid dry sweeping. I still see it everywhere, dry sweeping. So if you can vacuum up the dust at all, that's, fantastic. All of that accumulated dust still contains respirable crystalline silica. Respirable crystalline silica, it's inert. So all of that dust lying around, it still contains silica. If you resuspend it, you're still going to be potentially exposed to the respirable crystalline silica, by people moving over it, forklifts, other vehicles moving over it, etc. Please do not use compressed air for removing dust from your clothing. Again, it's something I see time and time again on sites, operators using compressed air to remove dust from clothes. Again, the dust still contains respirable crystalline silica. A lot of operators, they'll remove their RPE, they're going for break, they'll blow down their clothes with compressed air. There's risks associated with using compressed air anyways, but they're just resuspending the dust that contains respirable crystalline silica and potentially exposing themselves. And to mention health surveillance, okay, so I'm not an occupational health physician. However, if your operators are potentially exposed to respirable crystalline silica, it's a very good practice to have health surveillance plan in place, okay? So just because you're dealing with a carcinogen in the workplace, you don't necessarily have to have health surveillance in place. However, if your chemical risk assessment or your OC hygiene monitoring data indicates that the operators are exposed to respirable crystalline silica, you should have a health surveillance program in place, and that typically contains lung function testing, for example, or even chest x-rays. The only way to diagnose silicosis is via chest x-rays. So like pre-employment medical chest x-rays and then annual lung function testings, that is good practice when you have operators exposed to respirable crystalline silica. Okay, so finally, we're going to mention respirable crystalline, respiratory protective equipment. So we looked at the hierarchy of exposure controls and we saw the very bottom of hierarchy of exposure controls is PPE. So respiratory protective equipment is a type of PPE, okay? So PPE is bottom of the hierarchy of exposure controls because number one, it is expensive, it has to be fit tested, it has to be maintained, it's down to the operator to use it correctly. It's only protecting the operator, it's not protecting any bystanders from secondary exposure. But unfortunately, it is still used as one of the primary lines of defense in the construction sector. So a lot of the time, operators are just given respiratory protective equipment to protect them against respirable crystalline silica, and this is very poor practice. And so you should be implementing engineering controls first and foremost, and then also implementing respiratory protective equipment as well. So using an engineering control and RPE is usually the best practice when there's potentially, overexposure to respirable crystalline silica. Right, nuisance grade dust masks are not classed as PPE, okay? So these nuisance grade dust masks that you buy in Woodies or in other hardware shops, it's very important they are not classed as PPE. They will offer no protection against any sort of dust in the workplace, and especially respirable crystalline silica. Face coverings like we used during COVID or surgical masks, again, they are not classed as respiratory protective equipment. They will offer zero protection, okay, against airborne particulate. As I mentioned, RPE is worn as last resort. So if you are potentially exposed to respirable crystalline silica, you should be using, if you're using a disposable dust mask, it should be an FFP3 disposable dust mask, which will provide an APF of 20, a protection factor of 20, okay? Or a negative pressure mask, a half face or full face mask with P3 filters, okay? Or if your operator has facial hair or if you're exposed to extremely high concentrations of respirable crystalline silica, you can provide a PAPR unit. So that's a powered air purifying respirator. Any negative pressure RPE, so that is one that relies on a tight face seal. So that is your disposable dust masks, your half face masks with filters, your full face mask with filters, any ones that rely on a face seal. They have to be worn properly and they should be fit tested, okay? And the operator should not have more than 24 hours facial hair growth if they're wearing negative pressure RPE. If they're sporting a beard, if they have more than 24 hours facial hair growth, they should be wearing a PAPR unit, which is one of the loose fitting head units with a filtration device on a belt, okay? And then it feeds filtered air up into the headpiece. A PAPR unit will provide a protection factor of 20 to 40, depending on the head top that is used with the PAPR unit, okay? So again, it's important. It has to be a particulate filter if you're dealing with dust or respirable crystalline silica. Again, a lot of the time I come on site and operators are exposed to particulate or respirable crystalline silica and they're wearing the wrong filters. They're wearing ABEC filters, for example, which are charcoal filters. They will provide protection against solvents and vapors, for example, but no protection against particulate. So it has to be a particulate filter, okay? A P3 filter for your half and full face masks, or an FFP3 disposable dust mask. Okay, so because we are primarily dealing with males in the construction sector, I have to put in an additional slide, okay, about facial hair, because it is something that we run into a lot. So if an operator is using a dust mask or a half face or full face mask with cartridges to protect them against respirable crystalline silica, you have to be clean shaven, okay? So theoretically that means a person who is unshaven, which means they have not shaved within the previous 8-hour period to the work shift, we cannot guarantee the effectiveness of that dust mask, okay? So you have to be clean shaven in order for a negative pressure RPE unit to provide, the appropriate protection factor. So you can see there at the top of this slide, you can see that's an image of facial hair, for example, and you can see the silica dust sitting on that facial hair. So it just illustrates how small silica dust is in comparison to facial hair. So even a tiny bit, even just 24 hours facial hair growth will break the seal, it will affect the seal, and it will allow that silica dust to infiltrate the mask. So if your operators are sporting beards or they're not shaving, they'll have to wear a PAPR unit, okay? So there's that's a 3M VersaFlow PAPR unit head top there at the bottom of the slide. And that is a positive pressure unit, so you don't have to be fit tested and you don't have to rely on the negative pressure seal so they can sport as much facial hair as they want. Okay, it's just important to mention that since a lot of operators sport facial hair nowadays. And so we're just coming to the end now. So I just wanted to mention here in Shore Control Safety, we do have an occupational hygiene team, okay, which means our jobs is that we come on site and we can measure your operator's exposure to respirable crystalline silica and to other dusts, to wood dusts, non-specific dusts, respirable dusts. So if you carry out your chemical risk assessment on site and your risk assessment indicates that the operators are potentially overexposed or exposed to respirable crystalline silica, we can come on site and we can quantify the operator's exposure to respirable crystalline silica or any other dust to compare them to the occupational exposure limit values. Okay, so that's what we call compliance monitoring. So we can do that here in Shore Control Safety for you. We can come on site and measure your operator's exposure to silica dust and other types of dust to ensure they're compliant with the exposure limit value and they're not at risk of exposure to hazardous levels of those dusts. Just to mention some guidance and tools as well, okay? So the CIF, they have published a guidance manual, so the link is there, and they've also published some toolbox talks. So these were published a few years ago, but it's a guidance manual, okay, for assessing risks from worker exposure to respirable crystalline silica on construction sites. So that's a very good resource. And they also have some toolbox talks for specific tasks on the construction sites involving respirable crystalline silica. And the HSA also have some resources, but it's the HSE, the Health and Safety Executive over in the UK. They have some excellent resources for respirable crystalline silica, and they have toolbox talks, they have COSH essentials sheets and everything. So the HSE over in the UK have some really excellent specific or resources specifically for silica in the construction sector. Okay. Just to mention the construction professional Skillnet. Okay, so here are some other training courses that are available. Okay, for construction professionals under Skillnet. And also just to mention funding opportunities, okay, also under Skillnet Ireland. So I think I am out of time now. So if there is any questions and answers, you can pop them in the Q&A section.
Catherine, thank you so much for that presentation. We do have a number of questions. I don't know if they're visible on your screen.
And just bear with me now. I will try Q&A. I have them here. Perfect. Yes. Yes, so Owen has asked, in the hierarchy of controls, can you explain the difference between an engineering control and administrative control? Yes, so there is a big difference between those. So an engineering control measures, so engineering control measures would typically be your local exhaust ventilation, your water suppression, etc. And administrative control would be, I don't want to say wishy-washy, but an administrative control would be typically like task rotation, staff training, maintenance of tools, for example. So we would describe administrative control measures as fallible. So administrative control measures are excellent when you're using them in conjunction with other engineering control measures, but they're no good on their own. You cannot use an administrative control measure on its own. It's just too weak, if you know what I mean. So administrative controls typically would be training, task rotation, inspection, SOPs, for example. So they would be examples of administrative control measures, as opposed to engineering controls, which would be more of, it would be a stronger, a much more effective control measure. So in a nutshell, don't use administrative control measures on their own. That wouldn't be good enough. They're too prone to misuse, whereas engineering controls are a much more effective control measure. I hope that answers your question. I can leave my email anyways if anyone wants a more detailed answer. Edward asks, can you clarify legal requirement for face fit testing? Unfortunately, this is a bit of a grey area. But if you are using any negative pressure RPE in the workplace, it is always strongly advised to fit test. So there's two types of fit testing. There's quantitative fit testing and qualitative fit testing, okay? So quantitative testing will be using your port account machine, for example, and then qualitative testing would be using saccharin or sweet or salty mixture. But that is qualitative, that is very much it's subjective on whether the operator can actually taste the solution. A quantitative one, it is much, it's a better form of fit testing, in my opinion. So there is, to the best of my knowledge, in Ireland, there is no legal obligation for fit testing. However, in the UK, I think there is a legal obligation for fit testing. But for amongst health and safety professionals, we strongly advise that you do fit test, okay? So if you are relying on a negative pressure face piece to protect your operators from any sort of chemical hazard in the workplace, it is strongly advised. I don't think there's a specific legal obligation. However, it is strongly advised, and we would always recommend, if you're relying on negative pressure RPE, that it is fit tested. And to the best of my knowledge, the HSA also would be looking for that as well. The HSA would want you to fit test your negative pressure RPE.
Thank you, Catherine. I think we've all of the questions under the Q&A, but we've a number under the chat function.
Okay.
if are
Yeah.
visible to you. If not, I can call them out.
Do chat. Okay. And what class filter is needed on the vacuum? It would be a H class filter or a HEPA filter. So we'd always recommend for silica dust, we'd always recommend a H class vacuum and a HEPA filter. Or is a cyclone and then to vacuum better? Once you have a H-class vacuum, and the HEPA filter really is the most important thing when you're dealing with vacuum units for your construction sites, because the respirable crystalline silica is so fine. So the HEPA filter is the most important part of it. I know there's all sorts of types of vacuum cleaners available, but once you have a HEPA filter, on the vacuum, that is the most important thing to have in place for your vacuum cleaner. So it's M for wood dust silica. Yeah, so it would be the H class and the HEPA filter for the silica dust. If you use an FFP3 dust mask, yes, it absolutely needs to be fit tested. So any what we call negative pressure RPE. So negative pressure is any disposable dust mask, your half face with your cartridges or your full face with your cartridges. Anything that relies on the face seal is what we call negative pressure, and they all need to be fit tested, ideally quantitative fit testing. We can also do that here in Shore Control if you require a fit tester. I don't know, are the slides being shared, John?
If you're comfortable, we can certainly make them available. So
Yeah,
people
that's
will
no
get a
problem. Yeah,
excellent. So people will get a CPD cert, so we can ensure they're shared in accompaniment.
yeah, I've no problem sharing the information, if it helps out at all. Thank you. You're very welcome. The JSP respiratory would press to check an option for fit testing. JSP respiratory would press to check. So Rory, is that a PAPR unit, or is it a negative pressure? If you could share more specific information on that unit, I can answer that question. Restrictions around disposal of slurry after cleanup. Yes, Kenneth, too. And the best of my knowledge, I think it's classed as hazardous waste. Now, I wouldn't be a hazardous waste expert, but to the best of my knowledge, it contains respirable crystalline silica, which is a carcinogen. So to the best of my knowledge, it is classed as hazardous waste because it contains respirable crystalline silica. So to the best of my knowledge, you would need to dispose of that as hazardous waste, to the best of my knowledge. But again, I'm not a hazardous waste expert, but I believe it is classified as hazardous waste, and it has to be labelled appropriately. So if you have your slurry after the cleanup, you'd need to dispose of that as hazardous waste, and don't forget to label the outside of your bag to indicate, the contents of that hazardous waste stream. So make sure that you label it and make sure that you indicate that there is respirable crystalline silica present in the hazardous waste stream. Okay, you're very, very welcome. Thanks, makes sense. I hope so. Oh, here we are, Rory. Okay, so I'll just try and open this up. The JSP, I'll be able to. I can see that maybe. Okay, so it's a JSP with. Sure, if I'm able to see this with the screen. Oh yeah, okay. Oh, I see, here he is. Okay, yes, oh yeah, it's the JSP one with the half face, a face fit check. Yes, okay, I know what this means. So basically a daily face fit check is different. So a daily face fit check is something you kind of put your hands over the filters, for example, and that'll give you an idea of whether the mask is kind of sucking onto your face or whether that negative pressure is in effect. However, you will still need to fit test that. You'll still need to do a proper quantitative fit test for that mask to make sure that it fits you in the first place. So not all negative pressure masks fits everyone. So everyone has different shapes of faces, sizes of faces. If somebody has molars or dentures, or even if they have moles on their face, for example, that can all affect whether a certain mask fits somebody. So if you are wearing any sort of negative pressure face mask in the workplace, it should be fit tested to make sure that fits your face, initially, because sometimes if I'm carrying out fit testing, I may have to bring 4 or 5 different models of masks, for example, because not every mask fits every individual. So yes, you'll still need to have that fit tested, professionally fit tested as well. Because what this is referring to is an everyday face fit check, which is different to actual proper face fit testing. I hope that answers your question. Okay, is there
Excellent.
any
Well,
questions,
I
John?
think you've I think you've got through all of the questions. Well done, Catherine. And just on behalf of the construction professional Skillnet, thank you so much, Catherine, for your presentation and for all of today's attendees. The intent is to share a CPD, start with yourselves, and we'll also endeavour to share the PowerPoint slides as well. So unless there's any further questions, again, sincere thanks to Catherine, and yeah, we'll wrap it up there.
Okay. Thanks very much, everyone.
Thank you.
Have a nice day.